To our shareholders, I just wanted to introduce you to the Oona project through a fly-through. I'm going to start off here at the Silverado area. This area contains a lot of zinc and silver, hence the name Silverado. It's part of the Oona formation. Sorry about the camera work. I'm now straightening up and we're aiming towards the main zone, or the start of the main zone at Oona. This is about 1.5 kilometers away from Silverado. As you can see, there's a lot of space in between, there's a lot of opportunity in between, and there is some high conductive zones throughout this area that we're currently flying over. We're now reaching one of the highest zones of the Oona formation, and we're calling it the start of the Oona main zone. This area here has a lot of copper at surface. There's a lot of copper in those hills that we're flying over now. Lots of green malachite, lots of zinc. You can see me standing there. Standing on the hill, looking down. We're looking at hole 19P now. We're then going to go across and have a quick look at hole 14P. And over there is 18P, just at the foothills there. We're now flying across, and we're seeing hole 13P pop up. And we're about to see the start of hole 15P. Now, most of these zones that we're drilling here are testing high conductance and were some of our better holes in the first campaign. We're testing for copper, zinc, and gold within that program. We're now flying up to hole 16P. Hole 16P is really designed to test the magnetic gold intrusion that we believe is related to bomb diggity. We're also now seeing a couple of the old holes that we drilled from our first campaign. We're trying to use as many pads as we can as possible to reduce the costs. We're now flying north towards 17P. Now I'm quite excited about 17P. There's a high conductance zone. This area has a lot of copper at surface, a lot of zinc at surface, and it's some of the most altered ground that I've personally walked. So we're very excited to be able to drill this area, hole 17P. We're now flying across, and we're going to test some of this bomb diggity cluster, which has a high mag, high gravity, and high conductance, which was found with the VTEM. So this cluster is around 900 meters from the main Oona outcrop. We're really excited to drill test these, as we believe that there's potential extensions of the Oona formation sitting underneath some of this ultramafic. As you can see, there's the bomb diggity area in the background. So we're just coming on to 20P now. That's 20P. Again, that's testing a high mag, high gravity, and high conductivity. We're now flying over to hole 7P. 7P is also testing a high mag, high gravity, and high conductivity zone. Finally, within this video only, we're flying over to 8P. Now, 8P is really designed to test the high mag and high gravity at the bomb diggity intrusion site, the main zone there. Now, I do apologise. We still haven't done the pads for VT1 and VT2, so I can't include that in the flyover currently. But I thought it was very important to demonstrate to you, the shareholders and potential shareholders, the scale of the Oona system, which you just can't grasp when looking at some of the maps that we release. What I intend to do next is I intend to take you into a 3D section now to show you what lies beneath the surface of this area, to show you the geophysics that we've conducted and to show you the targets that we found. Shareholders, I just wanted to take you through our project file of the Oona project that we've developed in 3D. As you can see here, in this area here, this is Silverado. We then have the main Oona system, which goes right up to 17P. We then move into the Bomb Diggity cluster and Bomb Diggity itself, which is this area in here. We then move on to VT2, and as you can see down here by itself is VT1. Now what's really interesting is VT1 sits at the very end of our forecasted mineralized horizon, which is basically a large fold which wraps around the system and ends right through here. Let me just take off the top view layer. Now, this is all the data that we've collated since acquiring the project in October of 2024. And I think we've done a really good job with this project. I think we've systematically defined a thesis, a geological thesis, by using soils, rock chips, IP, magnetic surveys, gravity surveys, drilling, and then VTEM surveys. The first point of call which I'd like to show you is the IP survey which we conducted earlier this year and really was the design for our first 6-hole drill campaign which took place in April. So these are the IP slices, 1, 2, 3, 4, 5, 6, 7, 8. Originally, we had planned to do 5 lines. However, every line we did kept finding or mapping a high chargeability zone. Unfortunately, we couldn't go any further north or south because the team that we had employed to do the job had to get to another job, which is absolutely fine. The disseminated zone or the chargeable zones are definitely open to the north and south, as you can see within this image here. Now, this big purple zone here is what we have named the Bomb Diggity area, and we believe that Bomb Diggity is an intrusion. As you can see, Bomb Diggity is very large. It starts at surface, basically goes down 1 kilometre. It's about 1 kilometre long, and it's 900 metres from the actual outcropping Oona formation, which sits through here. What's important to note is what I call one of the magnetic fingers of Bomb Diggity, or it looks like it's related to Bomb Diggity, runs through the Oona formation. When drilling in our first campaign, hole 2, which is roughly in here, intersected this magnetic zone, and what was found was a gold and bismuth overprint. The mineralization looked different, and we firmly believe what we intersected in that hole is related to the Bomb Diggity intrusion. We've designed a number of holes in this campaign to test that thesis, and we're very excited to test it. What's interesting to note is that the Oona sits within a low conductive zone, as you can see. However, there's numerous surrounding areas which have higher conductance. And we're really interested to test these zones because we're trying to work out, is the Oona formation, which we can see an outcrop, is that actually distal? Is that distal mineralization and alteration to the main zone? Or is it further away from the original feeder structures? And that's a question we're aiming to answer. Why is that important? Well, we were hitting good mineralization through this central zone at Oona. Our best hole was 55 metres at 0.55% copper in hole 3. Hole 4 had 140 metres of copper mineralisation with a best intercept of 60 metres at 0.45% copper. Every one of the holes that we drilled across the Oona formation was 150 metres spaced away from each other, and every hole hit mineralisation. So again, it's about scale. What didn't quite add up to myself and Russ was, well, we've got this giant system. Well, it appears to be giant. It's quite large at surface. It's very evident that a lot of fluid has gone through it. There's a hell of a lot of alteration. There's really good mineralization. And those intercepts for us didn't quite justify those IP responses. We firmly believe that this is a SEDEX system, and that may change, but for now we believe this is a SEDEX system. Within SEDEX systems, you'll usually have higher grade zones of sulfides. They usually carry massive sulfide zones. And that was the main reason we conducted the VTEM survey. Now, as you can see here, this design or this outline here is the outline of the entire tenement, the entire Oona tenement. And we decided that we should be doing a VTEM survey across the entire tenement. So within this main zone, we did 100 metre spacing. In the wider extent, we did 200 metre spaced lines. However, in this section here at VT1, we infilled with 100 metre lines. So we have some really good high resolution data that's come through. Now, again, I mentioned it before, what it really found was a body of high conductivity, which is all around Oona. Oona is interesting in the fact that it sits within low conductivity, so we're very bullish about that. It really asks the question, or it begs the question, well, what's all of this? Is this better mineralization, or is it lithological? And that's something we will eventually have to answer. What's really exciting are some of these conductors that we've got, specifically VT2, which is about a 500 to 600 meter long conductor. One of the best geophysicists in the world, who's an expert in VTEM, firmly believes that is a sulfide conductor. So the question really sits, well, if it is a sulfide conductor, what sulfide is it? Now, we need to drill it to really confirm if that is a sulfide conductor. However, the data that's modeled up is showing that it looks like a sulfide conductor. We also have VT1, which is another very strong sulfide conductor. It was described by Kate, who is one of the leading experts in VTEM, that these look like sulfide conductors. This one is another one that's about 400 meters long, most likely continues at depth. So we're very excited to get out and drill these two areas in the next campaign. However, we're also very excited to drill all 14 holes in our campaign. We're extremely excited about the Bomb Diggity cluster, which is this area here. The Bomb Diggity cluster has the large Bomb Diggity magnetic intrusion. It's got the high mag fingers, it's got these high gravity components in white, and then we've got these high VTEM conductors sitting underneath it. We're planting 2 holes into this to really understand what's happening. I'm really excited to get onto 17P, which sits in this zone here. 17P, when you walk it, you see all the alteration. It's very intense. You see all of the good mineralization, and there happens to be a high conductive zone underneath it. I'll just run you through some of the other holes now. We've got 8P here, which is again going to test the Bomb Diggity intrusion theory. We've got a high mag and high gravity zone that we're drilling through. We then have 14, 13, and 16. These, again, are really aimed at testing the high mag structure
within the Oona formation, which appears to host gold. What we're trying to do is get some better intercepts of this magnetic structure in hope that we get some thicker intercepts of that gold bearing intrusion, or what we're calling an intrusion for now. Hole 19 and 18, again, high magnetic zones, really designed to test both copper and gold. This area here is highly altered, and there's some good conductivity underneath it also, so we're quite excited about this. Hole 15P is an interesting IP target which has a high resistivity and a high chargeability zone, which could be a massive sulfide at depth, and we're really testing that anomaly. We understand that there's no conductor there, however, VTEM has its depth limitations, so we need to test that hole. And that really takes us through our drill campaign. But what I wanted to show you is we have a lot of data, and we're not just drilling things for the sake of drilling things. We're drilling things because we've spent the money, we've done the correct work, we've got a lot of data sets, we've got a lot of data points, and we're able to drill all of these data points. This next campaign is really designed at asking some really big questions. If any of these big questions are successful, it will enable us to do a much better job in the future with potential resource drill outs, and really helping us to define what this system is, how big it could potentially be.
So thank you for your time today, shareholders. I really hope that this was an informative video. I really hope that you'll stick around for our drilling campaign, which we're aiming to start around Monday or Tuesday next week. We're really hoping that we have some good success, because if we have any success here, we firmly believe that Litchfield Minerals and the Oona project will change its trajectory and reward the shareholders for coming along for the journey. Thank you very much.